First thing we're going to talk about is how to plot a polar point P, which has the coordinates r, comma, theta. The way you do this is you're going to start on the 0 degree angle, and you're going to rotate in a counterclockwise, just like, again, the angle tells you. So you're going to rotate, let's say, a generic theta up. And then r is going to tell us how far out to go to plot the point. So let's say this is a length of r, so we're going to say that's length r, and then it represents that point right there. Again, we will label that point P. So pretty much when you're working with polar coordinates, it's always listed the r length and the theta, and so it's always in that order. So the first thing we're going to do as far as an example is we're going to practice plotting the point 350 degrees. And so again, this is your r, that's your theta. We're going to rotate 350 degrees, so that would put us at right there. Again, if you go all the way around, that's 360. 315 is 45 degrees shy, so that leaves a reference angle of 45 degrees. And then you're going to go out a length of 3. So if I just say we're going out 3 units out, then it plots this point right here. And again, that would be plotting that point, point A. It's at 3,315 degrees. For part B, let's go ahead and plot the point -2 pi. So again, because you have your r, comma, theta, theta is telling us to rotate pi. So that would put us all the way over here. Again, from here to here would be the angle pi. If this was a +2, you would go out 2, and then your point would be right there. However, because it's a -2, we're actually going to reflect it back in the other direction, 2. So it actually gives us this point right here. So that's going to be our point B. So again, we rotate pi, and then r tells us how far to go out. And so if we went out +2, it would put us there, but because it's a -2, again, you're going to reflect it back in the opposite direction to become that point right there. For our point C, we're going to do -1, -pi over 2. And when doing this, we're going to rotate -pi over 2, which puts us down here. Again, if that was a +1, we would go out 1, and then your point would be right here, but instead you're going to reflect it back. So again, if there were units on this, I want to point out sometimes you'll see pictures where they will have circles going out in this direction. And so if that was the case, again, -pi over 2 rotates down. And then again, we would come out 1, but because it's a -1, it's actually going to reflect it up in the opposite direction, which puts us at that point right there. Because we're going out 1 unit, or like, if you kind of want to think of it as a radius of 1. So that gets us to plotting point C. The next example says, find another representation of the polar coordinate 5 pi over 4, in which, in part A gives us the condition that r is positive and that theta is between -4 pi and -2 pi. So the first thing I want to do is plot the point 5, comma, pi over 4. And so if I plot that point, I'm rotating 1/4 of pi, which gets me right here. And then I'm going out 5 units, so let's say, puts me at that point. So again, this is the polar coordinate 5, comma, pi over 4, and we need to write another representation of that point with this condition, that r is positive and that theta is between -4 pi and -2 pi. So what I'm going to do is, if I rotate in the negative direction all the way around to here, that would be -2 pi. But the thing is, we need to get all the way back to this angle, so if I rotate another 1 pi and 3/4 of pi, it gets me to the right angle. So again, we went -2 pi. I'm going to write that down. And then we went another -1 pi. And then to get finally back to this angle, it's going to be a -3/4 of pi. So if you do negative 2 pi, negative 1 pi, that's negative 3 pi, and then another negative 3/4 of pi. So negative 3 and 3/4 of pi. You could definitely also write that as an improper fraction also. And then we're still going out a distance of 5. So we have a point, another representation for that point, and again r is positive, it's positive 5. And then our angle, negative 3 and 3/4 pi, does fall in between the desired condition. For part B, again, we're going to do the same thing. If you have your point right here, again, you're out 5. We need to, this time, write a point that represents our coordinate that represents that same point, but this time we want r to be negative and theta to be between 0 and 2 pi. So if I were to kind of draw a line right there and think about it going this way, you're going to be going in the positive direction 1 pi and 1/4 of pi. If I were to just say positive 5 right here, that would put me down in this quadrant 3. But because it wants that r is negative, if I show that it's a negative 5, that reflects me back and it gets me to the desired point. So again, negative 5 comma 1 and 1/4 pi is another representation for that exact same point with these conditions. And we're going to do one more example, part C. We're still dealing with the same angle, or excuse me, the same point, pi over 4, and then out 5. For part C, it says that the condition is r needs to be positive and theta will be between negative 2 pi and 0. So if I rotate in this direction, in the negative direction, again, that would be negative 1 pi. And then we're going another negative 3/4 of pi. That gets me to that angle. So we can write that as negative 1 and 3/4 of pi. And then again, they want r to be positive, so we just go out 5. So that point will then represent the same point we desire, where r is positive, it's positive 5, and then negative 1 and 3/4 pi falls in between the negative 2 pi and 0. Next, we're going to go over the relationship between converting from polar to rectangular coordinates. So what I'm going to do is draw an xy axis, and I want to think about rotating a generic angle theta in quadrant 1. If that's our theta, from our past, we have that if we drop a perpendicular to the x-axis, we can think of that as a generic x value, and then your height would be a generic y value. And I'm still going to think of this as r. If that's the case, then using your trig identities, you know that sine of theta by SOHCAHTOA is opposite over hypotenuse. So with respect to theta, opposite would be y, hypotenuse will be r. I'm going to continue with cosine of theta, would be adjacent over hypotenuse, so my adjacent is x, my hypotenuse is r. And then finally my tangent of theta by SOHCAHTOA would be opposite over adjacent, so my opposite with respect to theta would be y, and then my adjacent is x. I should probably label this a right triangle. So what we can do is actually, if we were to take this equation, and if we were to kind of isolate the y value, let's actually start with cosine. Let's isolate the x. In order to do so, you would times both sides by r. So you actually get the equation x equals r cosine theta. We're going to do the same thing like I said with sine. We're going to times both sides by r. It cancels the r's, so that y equals r sine theta. And then we're going to leave tangent as is, But before I do that, I'm going to write down that using the Pythagorean theorem, we're going to get x squared plus y squared equals r squared. And then again, I'm also going to include tangent of theta equals y over x. So pretty much these 4 equations are going to be very important. Write them down, highlight them, box them, don't lose them. So we will keep referencing those 4 equations in the next couple of examples. So in this next example, it says find the rectangular coordinates of the points with the following polar coordinates. So the first polar coordinate for part A is 3, pi. So there's actually 2 ways to do this. There's an easy way, and then there's the way that I just wanted to demonstrate using the equations we just went over. So again, this is r and theta, and we are trying to write a point in x and y. So again, I'll kind of go over the quicker way in a second, but first I want to practice using those equations. So your first equation is x equals, again, r cosine theta. So pretty much I'm going to take x, I'm going to plug in r as 3, and cosine of theta, I'm going to plug in pi for theta. If I find cosine of pi, it's going to be -1. And so therefore x equals -3. We're going to do the same thing for y. The formula, again, you need to memorize is y equals r sine theta. And same thing, we're going to take r, plug it in, and we're going to take our theta, which is pi, plug it in. When you calculate this, you're going to do sine of pi, which is 0. And so 3 times 0 is 0. And you end up getting your coordinates, x equals -3, y equals 0. And that's the rectangular coordinates, -3, 0, which corresponds to the polar coordinates, 3 pi. And I want to, again, like I said, demonstrate that you can also look at this. If I were to graph this point or plot this point, I'm going to rotate pi, which gets me all the way over here. And then I'm going to go out 3 units, and it puts me at that point. And actually, again, if you just look at this like a normal x and a y axis, you can see that that point is also -3, 0. So if you can just see that, obviously that's way more convenient. I just wanted to show that you can demonstrate using those equations to get the same point. So again, here is the rectangular coordinates for that given polar coordinate. So let's go ahead and do that with part B. Part B, just to look at it, we're rotating pi over 6, which corresponds to 30 degrees. And it's a -10, so instead of going out 10, we reflect across, which puts us down here. And just, again, we'll say that that is a a length of 10. Also, I want to point out that if this is 30 degrees, then we're rotating 180 degrees plus another 30 degrees. So we're putting us at 210 degrees. So if we want to use, again, the 2 equations, we're trying to find how far in this direction, in the x direction we are going, and then how far down we are going to obtain that point using x and y. So let's plug it in. Again, I'm using the same r cosine theta, where r is -10. Plug in theta as pi over 6. Cosine of pi over 6, here's my pi over 6, 30 degrees, I have 1/2, I have √3 over 2, and a hypotenuse of 1. So cosine of pi over 6 would be adjacent over hypotenuse, so √3 over 2. And if you reduce this, you get -5 √3. We're going to do the same thing for y. Plug in -10. And it's sine of theta this time. Sine of pi over 6, going back to the same picture, sine is opposite over hypotenuse, so I get 1/2 over 1, which is 1/2. Reduces to -5. And so my rectangular coordinates in x, y would be -5 √3 and -5. Next, we're going to find the polar coordinate of the point whose rectangular coordinate is given. So again, we're given the rectangular coordinate 1, negative root 3, so we'll label this x and label that y. If I were to look at the picture, root 3 is about 1.7, so I'm going over 1, and I'm going down, say, 1.7-ish. So if I kind of put coordinates on this, I'm getting to be like around here. So again, that would be the point that corresponds to, that's 1, and that's negative root 3. When I want to find my polar coordinate, I can use those same equations that we were talking about, those 4 equations: x equals r cosine theta, y equals r sine theta, x squared plus y squared equals r squared, and tangent of theta equals y over x. So the first one I want to look at would be the x squared plus, oops, that's supposed to be a y squared equals r squared. And so I can plug in 1 for x, and negative root 3 for y. And it's equal to r squared when I square these and add them up. So you get, this is a negative root 3. It looks kind of messy, but negative root 3 squared. A negative negative is positive. Root 3 squared is 3. So what I'm getting is that r squared equals 4. That means that r equals plus or minus 2. The other angle, or excuse me, the other thing I need to figure out, so I know I have 2 options for for r. R can be 2 or negative 2. But I'm trying to find either this reference angle or the actual angle to get to this point if we want to think of this as a polar coordinate. And there's actually an infinite number of answers when we work this out, but let's go ahead and set up our last equation. We're going to use the tangent of theta equals y over x. Y is given as negative root 3, and again x is 1. So we're trying to find an angle that when we take the tangent of it, we get negative root 3 over 1 as our ratio. And just by looking at this, because you know most of these problems are rigged where that the angle will be either a 30, a 60, or a 45. Not always, but it is quite common. So if you just look at this, to me it looks like it's probably going to be like a 60-degree angle. So let's go ahead and try if that were a 60 degrees. So it's kind of a trial and error using an educated guess. If that was, again, our reference angle of 60 degrees, this would be a length of negative root 3 over 2. Again, if that's a 60 according to our special triangle. This side would be the 1/2. And I just want to verify that if I did multiply by the reciprocal, I'd get that, and then the 2's cancel. So I do get negative root 3, which is, again, what we wanted to get up here. So those are the same. So it is indeed a 60-degree reference angle. So again, we could write this an infinite number of ways, but let's go ahead and just say that r is 2, positive 2, and our theta, because that's 60 degrees, would be r pi over 3. For the next one, it says that x is 0 and y is negative 4. If you wanted to, again, use this equation, I'll make sure to write it correctly this time. X squared plus y squared equals r squared. Again, you can plug in 0 for x and negative 4 for y. So I get 0. This becomes 16. Therefore, r squared equals 16, and r equals plus or minus 4. If you wanted to set up this equation, tangent of theta equals y over x, I would plug in my y and my x. But actually, looking at this, that's definitely going to be undefined. So you're pretty much saying tangent of what angle equals is going to be undefined. So you have a couple of options. If you look at this point up here, 0, 1, or this point down here, just making sure that my picture is still in your viewing window, 0, negative 1. If I'm looking at these two points on the unit circle, either one, because of tangent being y over x, will make it undefined. So we could be at pi over 2, or we could be at 3/2 pi. But if you actually plot this point, 0, negative 4, it's actually going to be 1, 2, 3, 4 right here. So let's, again, because it's that rectangular point, I'm trying to describe this in polar coordinates. You definitely could just describe it as going out 4 and rotating 3/2 of pi. So again, that would be your rectangular coordinate for, or excuse me, your polar coordinate for the given rectangular coordinate.